Welcome to Currents Chem World. Good morning. In this video, let us see electromagnetic spectrum. What are called electromagnetic spectrum? Electromagnetic radiations give electromagnetic spectrum. There are two types of spectroscopy: absorption spectroscopy and emission spectroscopy. We will see in detail. Before we study electromagnetic spectrum, what are called electromagnetic waves? What are called electromagnetic radiations? These electromagnetic radiations give electromagnetic spectrum. Okay. So, what are called electromagnetic waves? Electromagnetic waves consist of two vectors, electrical vectors and magnetic vectors. Okay, you see here, this is electrical vector perpendicular, this is in plane magnetic field vector. They are perpendicular to each other and also perpendicular to the direction of propagation of light. Okay, now what are called electromagnetic spectra? Electromagnetic spectra are given by electromagnetic waves or radiations. Electromagnetic radiations gives electromagnetic spectrum. It covers a wide range of electromagnetic radiations from cosmic rays of very small wavelength to radio waves of longer wavelength. See, this is radio wave and gamma ray and next cosmic rays. Okay. The arrangement of all types of electromagnetic radiations in the order of their increasing wavelengths or frequencies is known as gives the complete electromagnetic spectrum. Okay. So, in this, let us look at the electromagnetic waves. There are different types of electromagnetic radiations. Gamma ray electromagnetic radiation, X-ray is another example of electromagnetic radiation, radio waves, microwaves, infrared, all are electromagnetic radiations, but they have different wavelengths, frequencies, so they and energies. Okay, the fundamental equation for spectroscopy is Einstein equation, E is equal to h nu. Okay, the energy of photon that is absorbed by the molecule or emitted by the molecule. So, as you see, as as wavelength decreases or as wavelength increases in this direction, the energy decreases. Okay, see E is equal to hc by lambda. As lambda increases, energy decreases. As lambda decreases, there is an inverse relation between energy and lambda. There is a direct relation between energy and frequency. As frequency increases, energy increases. Okay, there are 1, 2, 3, 4, 5. There are 6 types of electromagnetic radiations to give 6 types of spectra. They are gamma ray spectroscopy, that is called mass Bayer spectra. Mass Bayer spectra occurs due to gamma ray radiation absorption. Similarly, photoelectron spectroscopy occurs due to X-ray electromagnetic waves. UV visible spectra, infrared spectra, NMR, ESR and EPR spectra occurs due to nuclear electron spin transition that is induced by the microwave radiation. Microwave radiation induces electron spin transitions. Radio waves induces nuclear spin transitions. There are two types of spectroscopy: absorption spectroscopy, emission spectroscopy. Okay. When electromagnetic radiations are passed through an organic compound or inorganic compound, they are absorbed by the organic molecules or inorganic molecules to induce electronic transitions or vibrational transitions or rotational transition in the molecules, because the molecules have vibrational motions. As a result, they have vibrational energy levels. The molecules have rotational motion, therefore they have rotational energy levels. The molecules have electrons, so they have electronic energy level. Okay, the energy levels are discrete, you see, quantized. Thus, the wavelength of radiation which matches with the different energy separation is absorbed by the compound, and the remaining portion of the incident radiation is transmitted. Okay, so absorption spectra is due to transition from lower to higher excited energy state. It occurs due to electron jumps from lower level to excited level. The wavelengths. So next, how do you record the absorption spectra? Absorption spectroscopy. Spectrometer. A spectrometer is used to measure the wavelengths or frequencies of the light absorbed and their intensities of wavelengths of light observed as a function of wavelength or frequency. We'll see next. So, what is spectrometer? It records, this is the absorption spectrum, black color. This is the emission spectrum. They are mirror image to each other. Absorption, emission spectrum are mirror image to each other. Okay. So, a spectrometer records an absorption spectrum as a plot of the intensity of light absorbed versus their wavelengths, frequencies applied. Such spectra are obtained by absorption of electromagnetic radiations to induce transitions from lower level to higher levels are called absorption spectra. What are examples of absorption spectra? UV visible, IR, NMR, ESR or spectra are well-known examples of absorption spectroscopy. Okay, let us now study the emission spectra. See, it occurs due to transition from higher excited state level to lower ground state. Okay. The spectra is obtained by emission of electromagnetic radiations from the excited substances are known as emission spectra or atomic emission spectra, are also called fluorescence luminescence spectra. Okay, how do you cause first excitation? The molecules should be in excited state, so that when it comes to ground state, from excited state, it emits photon of light. The excitation is caused by heating the substance or electrically, thermally or by irradiation. Okay, by irradiation the electron jumps from lower level to higher level, so the substance is in the excited state. When it is in the excited state, it will give emission spectra. The excited compound emits certain radiations. When it comes to the ground state, a spectrometer which records these radiations intensities versus wavelength or frequency applied to give emission spectrum. Okay, let us now study the differences between the absorption spectra and emission spectra. As we have seen, the absorption spectra is obtained when electron jumps from lower level to higher excited levels. That is, it is due to transition from lower ground state to higher excited state. Whereas the emission spectra is due to when electron jumps from higher level to lower ground state levels. That is, emission spectra is due to transition from higher level to lower level. Okay. Absorption spectra is formed due to absorption of light energy, absorption of electromagnetic radiations or photons. Emission spectra is formed due to emission of electromagnetic radiations or energy, electromagnetic energy. Okay. Now, when several wavelengths of light, several frequencies of light are passed through organic or inorganic compound, a few of the wavelengths frequencies matching with the energy difference are observed. Okay, so you will the rest of the light is transmitted. So you have bright background and it contains dark lines. It contains dark line in the presence of bright background. In the case of emission spectra, it is opposite. Absorption spectra is discontinuous. Absorption spectra is mostly discontinuous. Okay, whereas it can be either discontinuous or continuous. What are the examples of absorption spectra? UV visible, IR, NMR, ESR. What are the examples of emission spectra? Fluorescence spectra are also called luminescence spectra and phosphorescence spectra. These are the examples of emissions, atomic emission spectra, etc. Thank you for watching. Please share and subscribe. Thank you again.